An AI ran its own robotics experiments overnight, nobody in the room, and taught a real robot arm to push a pin into a hole barely wider than the pin, and it got it right basically every single time.
Overnight, real arm, no human watching? Okay, take a guess. To count as solved, how many times in a row did it have to nail that pin? Pick a number and hold it.
And keep your eye on one small thing in the setup, a second camera pointed at the scene. It looks like a spare part. It's the whole reason this story stays honest. The through line is one cruel little task. A pin, a hole barely wider than it, a robot arm, and a coding AI handed the keys. 8 robots, 8 AIs, trading recipes like coders on an open source project, and one single idea that did almost all the work.
But wait, Juniper, robots learn by practicing, right? Just let it try over and over. That's basically free. Where's the problem?
That's the belief this breaks. On a real robot, practice isn't free. Every time the arm fails and drops the pin, somebody has to walk over, find it, pick it up, and set the whole scene back to the start. That reset is the hidden job. In a video game, you reload instantly. In the real world, a human is chained to the bench, resetting the mess, watching failures, and tuning the recipe. The paper calls it babysitting. And that human babysitter is what caps how fast robots learn, long before the algorithm does.
So how do you fire the babysitter?
You build a bench that resets itself. Picture a chemistry lab. A skilled person sets it up once, installs the gear, and decides what counts as success. Real work, but done one time. After that, a lab tech can run experiments all night without the chemist hovering. Here, the lab tech is a coding AI. The humans wrap the arm in software that does 2 things on its own. Put the scene back and judge whether the robot really succeeded, using cameras and force sensors. Then they hand over the keys. The AI writes the training code, runs the arm, reads what happened, rewrites the code, and runs it again.
And it just got better on its own?
It climbed. And out of dozens of ideas it tried, one did almost all the work. Hold on to that, Finn. Picture the night as a family tree of guesses. Dozens of branches, and most are dead ends. Tried, no gain, abandoned. But one branch lights up. A single tweak, gently pulling the trial and error learning back toward copying the human demos, jumps the success rate almost 11 points in one step.
Wait, one idea out of all of them?
One idea did most of it. The rest was polish. It kept climbing until the arm hit 100%, and it solved that pin faster than a top method that keeps a human in the loop. Remember the number you picked? The bar wasn't 10 in a row, or 20. It was 50 perfect insertions, back to back. And with 8 robots sharing recipes like open-source coders, they got there in a fraction of the time one robot needed.
And the second camera?
That's the honest part, Finn. With one view, the robot could line up an angle that looks like success, but isn't. The second camera checks from another side, so it can't fool its own judge.
Which is the catch, right? The AI writes that judge, then gets graded by it. It's a student grading their own homework. If the answer key has a blind spot, you can score 100 without ever being right. So here's the one to fight about. A robot skill taught overnight and graded by the machine itself. Would you trust it more or less than one a person signed off on? Drop where you land.
If you like AI research pulled apart in plain English, subscribe and join a growing crowd doing exactly that. One strange paper at a time.
The lights are still on in that lab. The arm's still moving. And nobody's home.